Hello and welcome. My name is Brian Chu. I'm a Microsoft technical trainer. I'm here to walk you through the AZ-800 Administering Windows Server Hybrid Core Infrastructure course. Let's get started. In this session, we'll explore network infrastructure services in Windows Server. You'll learn how to deploy and manage DHCP, implement DNS, manage IP addresses, and set up remote access. Let's start by looking at how to deploy and manage DHCP, or Dynamic Host Configuration Protocol. DHCP is a key service for automating IP addresses assignment and simplifying network management. DHCP is a network management protocol that automatically assigns IP addresses to devices on your network. It uses a four-step process called DORA: discover, offer, request, and acknowledge. When a device connects, it broadcasts a request, and the DHCP server responds with an available IP address. DHCP also supports IPv6 configurations and helps ensure devices always have the correct network settings. There are two main ways to install the DHCP server role: using Windows Admin Center or the Add Roles and Features wizard in Server Manager. You can optionally choose to run a PowerShell command. After installation, you need to make sure the server has a static IP address and the right permissions. You can also use PowerShell to set up management groups for DHCP. After installing DHCP, you must authorize the server in Active Directory before it can assign IP addresses. This step is important for security, as it prevents unauthorized DHCP servers from handing out incorrect IP addresses. If you detect an authorized DHCP server, you disable its service. Use the ipconfig/all command on the client to find out what server assigns its IP address. DHCP options allow you to specify additional network settings, like default gateways or DNS servers. Most options are set at the scope level, which means they apply to all devices in a specific subnet. You can configure these options using the DHCP console. A DHCP scope is a range of IP addresses that the server can assign to clients. When creating a scope, you define its name, IP address range, subnet mask, exclusions, lease duration, and other options. Not all IP addresses in a subnet need to be included. Some can be excluded for static assignments, like printers or servers. You can manage DHCP scopes using PowerShell CMD lists, such as add DHCP server for scope and set DHCP server for scope. If you want a device to always get the same IP address, you can create a reservation in the DHCP console. Reservations are useful for devices like printers that need a consistent address. To ensure DHCP is always available, you can implement high availability options like DHCP failover with the Windows Server failover clustering, or split scopes. These options help prevent service interruption if a server goes down, keeping your network running smoothly. DHCP failover allows two servers to work together to provide IP addresses. You can set up failover in load balance or hot standby mode. The configuration includes setting a unique relationship name, defining the maximum client lead time, MCLT, and enabling message authentication. This ensures clients can always get an IP address, even if one server isn't available. Next, we'll move on to implementing DNS, or Domain Name System, in Windows Server. DNS is essential for translating human-friendly names into IP addresses, and it is a core part of any network infrastructure. DNS provides hostname resolution for IP addresses and can also perform reverse lookups. The most common usage is resolving fully qualified domain names like server1.contoso.com to their IP addresses. DNS uses a hierarchical namespace and is the primary method for name resolution in Windows network. A DNS resolver is a server that handles DNS queries from clients. Clients cache responses for faster future lookups. Host names are user-friendly names linked to IP addresses, while NetBIOS names are used by some legacy applications. Windows computers can resolve names using several methods, including DNS cache, host files, and NetBIOS queries. In DNS, a zone is a specific portion of the DNS namespace, such as contoso.com. The zone is hosted on the DNS server. There are two main types of zones: forward lookup zones, which are used to resolve names to IP addresses, and reverse lookup zones, which resolve IP addresses to names. The most common record in a forward lookup zone is the hostname record, which maps a hostname to an IPv4 IP address. To create, edit, or delete resource records, you must use the primary zones, which is writable. Secondary zones are read-only copies of the primary zone, and they are used for redundancy and load balancing. Every DNS zone, whether forward or reverse, contains several essential records. These include the Start of Authority (SOA) record, which defines the zones and its properties, and also name server NS records, which identify the DNS servers for the zone. There are also pointer PTR records for reverse lookups and a time to live TTL value for each of the records. The TTL determines how long it is cached. Common DNS record types include A records for IPv4 addresses, Quad A records for IPv6 addresses, CNAME records for aliases, SVR records for locating services like domain controllers, MX records for email servers, and last, TXT records for storing arbitrary information. When you install the DNS role on the Windows server, you can create zones in two ways. If you create a zone file, it's a standard primary zone. If you store the zone in Active Directory Domain Service, ADDS, it becomes an Active Directory integrated zone. it is automatically replicated to the domain controllers. Secondary zones are always stored in files and are read-only. You can control zone transfers to enhance security, allowing transfers to any server only to server listed on Name Servers tab or only to specific servers. Each DNS zone can also be configured with the security settings for dynamic updates. It allows clients to automatically register and update their records. You can create DNS resource records manually using the DNS Manager, Windows Admin Center, or PowerShell. Dynamic DNS makes management easier by allowing clients to automatically register and update their records when their IP addresses change. Dynamic DNS registration is triggered by events such as the client starting up, the DHCP client service starting, or an administrator running the ipconfig/register DNS command. This automation helps keep DNS records accurate and up-to-date. DNS forwarding allows you to configure each DNS server with one or more forwarders. The forwarders are other DNS servers that handle queries the local server can't resolve. You can also set up conditional forwarding for specific domains, choosing whether to store the configuration locally or in ADDS. Stop zones are another option. They contain only name server records and participate in the zone transfers, helping to resolve information for a domain without synchronizing our records. The main difference between stop zones and conditional forwarders is how remote servers are selected for querying. Now, let's move on to IP address management, or IPAM. IPAM is a feature in Windows Server that helps you plan, deploy, manage, and monitor IP address spaces in your network. It provides centralized management for DHCP, DNS, and IP inventory, making it easier to track and allocate IP addresses efficiently. IPAM offers several benefits, including planning and allocating both IPv4 and IPv6 address spaces, monitoring address utilization and trends, managing static IP inventory, and tracking DHCP and DNS records. IPAM is organized into 4 modules: discovery, address space management, multi-server management and monitoring, and operational auditing and tracking. With IPAM, infrastructure staff can monitor and administer DHCP and DNS, determine where specific IP addresses are allocated, and collect statistics from domain controllers and network policy servers. When deploying IPAM, you need to choose a topology: centralized, distributed, or hybrid. In a centralized topology, a single IPAM server manages all DNS, DHCP, and domain controllers in the environment. The IPAM client, which can be the same server or remote management workstation, connects to the IPAM server to perform reporting and tracking. This setup is ideal for organizations that want a single point of management. In a distributed topology, multiple IPM servers are deployed, each managing a subset of the network infrastructure. This approach is useful for large organizations with multiple sites or departments that require separate management. The hybrid topology combines elements of both centralized and distributed models, allowing for flexible management based on organizational needs. Regardless of the topology, each IPAM deployment includes an IPAM server and one or more IPAM clients. To deploy IPAM, the server must be a member server in the domain and should be dedicated to IPAM tasks. The server needs access to the IPAM database and sufficient storage for logs and data. A single IPAM server can support up to 150 DHCP servers, 6,000 DHCP scopes, 500 DNS servers, and 150 DNS zones. To deploy IPAM, install the IPAM server feature, provision the server, and then configure and run server discovery to find management servers. If you install IPAM on a server with the desktop experience, the client is installed automatically. On server core, you need to install the client on another server or Windows client for remote management. The installation process varies depending on the operating system, but the core steps are similar. Install the feature, provisioning the server, and configure discovery. IPAM use role-based access control RBAC to define and establish fine-grained control for users and groups. You can customize roles, access scopes, and access policies. A role is a collection of IPAM operations that can be associated with a user or a group. There are 9 built-in administrator roles, but you can create custom roles as needed. Access scopes determine which objects a user can access, and access policies combine roles and scopes to assign permissions. This structure allows you to tailor IPAM management to your organization's needs. IPAM includes several security groups, each with specific privileges. For example, IPAM administrators have full access to all IPAM data and tasks, while IPAM MSM administrators can manage DHCP servers, scopes, policies, and DNS servers. Assigning users to these groups ensures that only authorized personnel can perform sensitive tasks. When setting up IPAM, you need to create several group policy objects to allow IPAM to monitor and manage DHCP, DNS, and domain controllers. When you select group policy provisioning, you will be prompted to provide a prefix for these GPOs for easy identification. To create the required GPUs for IPAM, use the invoke IPAM GPO provisioning PowerShell commandlet. If you run the commandlet without specifying a server name, the local computer account is added to the IPM UG group in Active Directory. You must ensure that the IPM server's computer account is a member of this group for proper operations. These GPOs configure the necessary permissions and firewall rules for IPM to manage your network infrastructure security. With IPAM, you can perform a variety of DNS management tasks. You can examine DNS servers and zones, create new zones, add DNS records, and manage conditional forwarders, and open the DNS console for any server managed by IPM. This centralized management makes it easier to maintain DNS consistency and troubleshoot issues across your network. IP address management provides a centralized way to manage DHCP servers across your network. With IPAM, you can view all your DHCP servers in one place, monitor their status, and quickly identify any issues. This makes it much easier to keep track of your DHCP infrastructure, especially in larger environments with multiple servers and scopes. Using IPAM, you can configure and manage DHCP servers in several ways. You can examine DHCP scope information across all servers, edit server properties, and configure options based on vendor or user classes. IPAM also lets you manage DHCP policies, import policies from other servers, and add MAC address filters to control which devices can retrieve addresses. You can activate or deactivate DHCP policies, replicate failover scopes to partner servers, and launch the DHCP console for any managed server directly from IPAM. IPAM also helps you manage DHCP scopes. You can edit scopes properties, duplicate scopes to use templates, create reservations for specific devices, and you can also add scopes to superscopes for larger networks. IPAM allows you to configure DHCP failover for high availability, import and activate policies, replicate scopes, and remove failover configurations or scopes from superscopes. IPAM automatically discovers addresses spaces and utilization data from the DHCP servers it manages. This means you always have up-to-date information about how your IP address space is being used. You can also import IP address information from CSV files. This makes it easy to integrate existing data. IPAM helps administrators detect overlapping IP addresses ranges on different DHCP servers. This can prevent conflicts and improve network reliability. Within the IPAM administration console, you can view and organize your IP address in several ways. You can see IP address blocks, which are the highest level entities, as well as IP address ranges and individual IP addresses. The IP address inventory view lists all IP addresses in your enterprise, along with device names and types. You can also group addresses ranges into logical groups, making it easier to manage large or complex networks. In Server Manager, the IPAM node organizes monitoring and management of DHCP and DNS servers into several views. You can view all managed DHCP and DNS servers, monitor DHCP scope utilization, and you can also enable zone monitoring for DNS. IPAM allows you to organize servers into logical groups, making it easier to manage and monitor your network infrastructure at scale. Now, let's move on to implement remote access in Windows Server. Remote access allows users to connect to your network securely from remote locations, supporting flexible work and business continuity. We will explore the different remote access options available and how to configure them for your organization. Windows Server offers several remote access features. VPN, or Virtual Private Network, creates a secure tunnel over the internet so users can access resources, data, and applications from anywhere. Routing allows the server to act as a router, supporting routing tables and protocols. Web Application Proxy provides reverse proxy functionality, enabling users to access internal web applications securely from the internet. The remote access server role brings these technologies together, allowing organizations to choose the best solution for their needs. There are three main types of remote access scenarios. First, remote access to data files, such as Word or Excel documents. It is typically handled well by VPN or direct access, though the performance may be slower than in the office due to network speeds. Second, remote access to desktop apps that use shared data storage can be slow over VPN because of high latency. In these cases, remote desktop services is often used, allowing the app to run closer to the data on the internal network. Third, remote access to web-based apps. This usually performs well, even over slower networks, because only small amounts of data are sent to the browser. Web-based apps are often protected by a reverse proxy and use HTTPS for secure communication. After installing the remote access role, you can manage it using the Remote Access Management Console or the Routing and Remote Access Console. You can also manage it with Windows PowerShell. The Remote Access Management Console lets you configure VPN and Web Application Proxy using a wizard-based interface. The Routing and Remote Access Console is used to configure the server as an NAT device, router, DHCP proxy, or VPN server. These tools provide flexibility for managing remote access according to your organization's requirements. When setting up a VPN, you need to choose a tunneling protocol. Options include PPTP, I2TP or IPsec, SSTP, and IKE version 2, each with different security and compatibility features. You also need to select an authentication method, such as PAP, CHAP, MISCHAP version 2, or EAP. All VPN protocols provide encapsulation, authentication, and data encryption to protect data as it travels over public networks. Network Policy Server, or NPS, is Microsoft's implementation of a radius server. NPS enables centralized authentication authorization, and accounting for network access, supporting a wide range of equipment, like wireless access points, VPN servers, and switches. NPS can also act like a radius proxy, forwarding requests to other radius servers, and perform radius accounting by logging authentication and access events. With NPS, you can create policies to control who can access your network, under what conditions, and track usage for security and compliance. When planning NPS, you need to choose an authentication method. NPS can log authentication and accounting requests to test files or a SQL Server database, providing a record for network access attempts. NPS authenticates and authorizes connections requests before allowing or denying access, ensuring only authorized users can connect to your network. NPS supports connection request policies and network policies. When a connection request is received, NPS compares it to each policy in order. If a policy matches, NPS uses it to authorize the request and applies the configuration settings. If no policy matches, or if the user's styling properties deny access, the request is rejected. This policy-based approach gives you granular control over who can access your network and under what circumstances. To secure remote access, you may need to deploy a public infrastructure PKI to issue certificates. You can create your own private certificate authority using Windows Server. Purchase certificates from a public CA or generate a self-signed certificates with PowerShell. Private CAs offer greater control and lower cost, but their certificates aren't trusted by external clients by default. Public CAs are widely trusted but more expensive. When planning PKI, consider how certificates will be used, who needs them, and whether automatic enrollment is required. Web Application Proxy is a remote access role service that acts as a reverse proxy, allowing users on the Internet to access internal web applications securely. Web can use Active Directory Federation Service, ADFS, to pre-authenticate users and acts as an ADFS proxy for publishing claims-aware applications. Before installing Web, you must deploy ADFS. Web is typically placed in a perimeter network between two firewalls, with ADFS and the published applications located on the internal network. Web supports two types of pre-authentication: ADFS pre-authentication and pass-through pre-authentication. ADFS pre-authentication ensures that only authorized users can access web applications, significantly reducing the attack surface. It also provides benefits like single sign-on, multi-factor authentication, and access control. In pass-through mode, Web simply forwards requests to the web application, which is responsible for authenticating users. You can publish web applications using the Web Console or PowerShell commandlets. When publishing an app, you'll need to specify the type of pre-authentication, the application to publish, the external URL, a certificate for the external URL, and the backend server URL. The web configuration wizard will also ask for the ADFS name, administrator credentials, and an ADFS proxy certificate. This process ensures that your web applications are securely accessible to remote users while maintaining strong authentication and encryption. Now, it's time for us to get a practical experience in Lab 7. This lab will guide you through deploying and configuring DHCP for high availability. You will set up DNS for a department with its own server and provide secure remote access to Windows Admin Center using Web Application Proxy. In this lab, we will implement and configure DHCP and DNS in Windows Server. First, let's launch Server Manager, and we will first do the configuration of DHCP. So let's select DHCP tab. And as you can see, DHCP service is already installed in SCA DC1. This time, we will switch to the Windows Admin Center, and we will do the DHCP configuration via Windows Admin Center. Before we can do that, we need to first install the extension of DHCP. So we select this service from the available extensions, and we get it installed. After the extension is installed, we can switch back to our server. But before we do that, we will install DNS again so that we don't really have to switch back to extensions. Let's make sure these two services are all installed here. After the confirmation, we will switch back to the server management. The first step, we will add the remote server. So this is the remote server that we would like to install the DHCP service. So we will select SCA SVR1. We will install the DHCP service on this remote server. So let's click this newly added remote server. And let's scroll down a little bit to find roles and features. And we will add the DHCP role onto this remote server. Let's click Install. Let's click Yes. This will kick off service installation. As you can see, the installation is in progress. All right, now the installation is complete. We can continue with the configuration of the DHCP server. This time, let's switch back to the server manager running on SCA admin 1. As we can from the server manager, configuration is required for the remote server. So let's complete the DHCP configuration from server manager. So let's click this one. Click next. So what we are gonna do now is we need to authorize this DHCP server in our domain. So we will authorize this action with the Contoso administrator account. As you can see, the process is successful. Now, since this DHCP server is an authorized one, we can do the configuration on it. So we will switch to the Windows Admin Center to do the configuration. This shows us that Windows administrators can choose their preferred tools to do the configuration. You can use Server Manager or you can use Windows Admin Center. So let's click DHCP. And let's first install the DHCP PowerShell tool. After this remote toolset is installed, we can follow up with the configuration later. Okay, so now we can create a new DHCP scope. So we will choose IPv4 as the protocol. And we give it the name of Contoso clients. We input the starting IP address and the ending IP address. And we also set up the subnet mask. We also need to configure the default gateway. All right, so we click Add. And we will type in the IP address for the default gateway. Last but not least, we will set the lease duration for the DHCP clients as 4 days. Let's click Create to complete the setup. Okay, after the scope is created, let's switch back to Server Manager on SCA Admin 1. You can easily pick up your work between different management tools. So we will choose the DHCP tool from Server Manager. And then we will manage authorized servers. So as you can see, these are the two authorized DHCP servers within this domain. Everything looks good. So next, we can add the authorized DHCP server into this management console. So we will first add SCA SVR1 and do the configuration on this remote server. So if we can expand IPv4, you can see that the scope we created via Windows Admin Center is listed here and has the status of active. Let's resize the window. And we can also select the scope options. So the default router setting is already included. We can add additional options. So for this demo, we will add the DNS server besides the default gateway. So let's scroll down a little bit and we select the DNS servers. And we will use our existing domain controller as the DNS server. And we click Resolve to resolve the IP address for this domain controller. And we click Add. It will validate the DNS resolution. Everything looks good. So we click OK. As you can see, the DNS option is already added into this DHCP server. Next, we will configure the DHCP failover. So there are two authorized DHCP servers in our domain. We will set up the failover between them. So we choose Configure Failover. Let's click Next. So from this management portal, this time we will add AZ-800 as the partner DHCP server for the failover. Let's click Next. And we will set up a relationship name for the failover. And here we can also set up the failover mode. Choose the mode as hot standby. Here, we will set a shared secret for the failover, and then we can click Next. After reviewing all of the settings, we can click Finish. All right. So the DHCP failover is completed. And next, we will continue with the failover setup. But this time, let's first add the domain controller with DHCP server feature installed into our DHCP management console. So let's select this domain controller and click OK. All right, and we will do the following setup right from this remote domain controller. So since this one is a hot standby, you will see that currently it is offline. As you can see, the console client's DHCP scope has already been replicated to SCA DC1 from our SEA SVR1. So what we are going to do next is we will do the configuration for the existing Contoso DHCP scope. So this time we click Configure Failover. And this time we will add the partner server as SEA SVR1. We will input the private IP address for the remote server. And then let's click Next. Okay, so it will find the existing relationship. So from here, we just click Next. And then we complete the failover setup for the existing Contoso DHCP scope. After all of the configurations are complete, next we can verify the DHCP functionality. And for the SEA SVR1, if we expand the section and we do a refresh, we will see that Contoso scope will be replicated. All right, as you can see, the existing Contoso DHCP scope is replicated from SEA DC1 to SEA SVR1. All good. Then we will do the verification right from this SEA admin 1. So let's first take a look at the network setting. As we can see from the network profile, now the IP is set up as fixed one, right? We manually configured the IP address for this Windows server. So what we are going to do next is we will change the network profile to use the IP address assigned automatically from the DHCP server. So to do that, we can edit the IP address settings. So we will choose Automatic DHCP from the drop-down list. And let's click Save. All right, as we can see, now the IP address is set to Automatic DHCP. And this remote server will have an IP address assigned from the DHCP server. So we can verify the IP assignment right from the address lists. It looks like our DHCP configuration is done successfully. You can find it also on the SEA DC1. All right, so for the very last step, we will change the DHCP setting on this network configuration. All right, you can verify that IP address list time from the settings in the network profile. So from the Ethernet setting, this time we will modify the properties of the Ethernet. So we will click Internet Protocol version 4, and this time we will manually input the fixed IP for this virtual machine. And we will set up the preferred DNS server. This setting will be used in our next demo for configuration DNS. All set. Now let's switch gear to DNS configuration. First, let's install the DNS on SCA SVR1. Now the service is available for us to install it. So let's click Yes to kick off the installation progress. As you can see, the installation is underway. All right, now the DNS server is installed on SCA SVR1. Okay, from the DNS tab, we can now create a new DNS zone. So first, let's install the DNS PowerShell tool. Okay, after the installation, we can continue with creating a new DNS zone. We will set the zone type as primary, and we will give it a zone name. So we will create a zone from a new zone file, and we will click Create. After the DNS zone is created, we can later on add DNS records in the DNS zone. So let's click the newly created zone. And from here, we can add a new DNS record. So here we will use a host A record. And we will set the record name as test app. And we will assign an IP address to this host A record. We will change the time to live setting as 600 seconds. And let's click Create. All right, so the record is created successfully. Now let's open a PowerShell from the local server, and we can test the DNS resolution from a command line interface. So for this one, it will resolve the newly created DNS record right on this SEA SVR1 DNS server. Let's run this command. Now you can see the DNS resolution is successful. The next step for us is to configure DNS forwarding. So let's just select the newly created DNS server, and then we launch DNS Manager. And on this SEA SVR1 DNS server, we click the Properties. From here, we can select the forwarders. And as the demo purpose, we can add the domain controller as the forwarder for this DNS server. Or we can set up a public IP address for the DNS forwarder. Okay. So it will forward the DNS resolution to this public DNS zone. Next, we will configure conditional forwarding. So let's first expand the SEA SVR1. And for the conditional forwarders, let's do the configuration here. So we set a new conditional forwarder. And we will type in the private IP address for our domain controller. So for the DNS domains, we will set the contoso.com. And then this is the IP address of the existing domain controller. Okay, so let's click OK. So with this setting, all of the DNS resolutions regarding contoso.com will be forwarded to SEA DC1 for resolution. So now it's time for the second command. Okay, as you can see, the DNS resolution is successful. Our final step is to configure DNS policies. We can do it right from the built-in PowerShell for SEA SVR1. So first, let's add the DNS server client subnet with the name head office subnet. And then we will create a DNS zone scope. So after the scope is created, we can continue adding DNS resource record. So for this one, it is a host A record. And this record will be added into the DNS zone head office scope. And finally, we can add the DNS policy. So this will allow the DNS resolution for the head office scope. All right, so the DNS policy is set up. This concludes our session. You've learned how to deploy and manage DHCP, implement DNS, use IP address management, and provide secure remote access for your organization. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.